Right, so this example is for the comparing proportional relationships in different formats. Okay, so we're looking at using tables, graph, words, or equations to represent and compare proportional relationships. Different cyclist rates are represented below. So we have cyclist A is written in words. Okay, cyclist B is a table. Cyclist C is an equation. And cyclist D is a graph. And what they want to know is which cyclist is faster. Okay. Again, it's hard because everything is shown differently. However, if you find each unit rate, then compare. Okay, so no matter how it's shown and how it's presented to you, you can find the unit rate. If you find the unit rate for each, you'll be able to compare and answer the question. Okay, so I just zoomed in a little bit. You don't need to write this down unless you want to take any notes, but for cyclist A, we have a cyclist can ride 24 miles in 2 hours. So to find my unit rate, I'm going to say how much for 1 hour. Remember, unit rate is where we take our denominator number, which is usually the time or like miles per gallon, whatever's after the per or in. Okay, so $8 per hour. Okay, $20. I made $20 in 2 hours babysitting. Okay, that in is the same as the per. That indicates that we have a ratio happening. Okay, so if it's 24 minutes for 2 hours, how much for 1 hour? Mental math gives you 12 miles in 1 hour. So for cyclist A, 12 miles, 1 hour. Cyclist B, we have a table. So in our table, of course, he went 0 distance in 0 hours. But if we look right here, if I create a ratio with my distance and my miles, it's 5 miles in 1 hour. So the table actually gives you your unit rate right here. Okay, so cyclist B is 5 miles, 1 hour. Cyclist C. Now when we have y equals mx, m represents my unit rate. So cyclist C is 9 miles in 1 hour. And finally, if I have a graph, I find 2 places that I have points that cross grid marks, and I'm going to find the slope. The slope is the unit rate. If it's simplified down, it's the unit rate. If I take my rise and my run and it's not simplified, that would just be like the rate of change. But if I simplify my fraction, I get my unit rate. So my rise is 10, my run is 1. So he goes 10 miles, 1 hour. Now if the slope, if doing the rise and the run makes you nervous, or it's the test day and you're not sure what to do, look here, 1 hour. I'm going to look at 1 hour and I'm going to say, at what point, distance-wise, did I go for 1 hour? Oh, look at that. 10 miles in 1 hour. Okay? So if I compare, cyclist 1 was 12 miles in 1 hour. Cyclist A. Cyclist B was 5 miles in 1 hour. Cyclist C is 9 miles in 1 hour. And cyclist D was 10 miles in 1 hour. And our question asked who was the fastest. So my fastest is going to be cyclist A, 12 miles per hour. Okay, so in 1 hour's time, cyclist A will get 12 miles, B will get 5 miles, C will get 9 miles, and D will get 10 miles. So my slowest would be B. And then it says you would need to explain how you got that. So then that's up to you, how you would explain that. You could say I found the unit rate for each cyclist, and whoever had the largest amount of miles was the fastest. Lowest amount of miles was the slowest. And that's it.